Hello everyone, welcome to another video from CodeML from scratch. In this video, I want to talk about the decision tree, which is a very powerful algorithm for classification as well as for regression problems. So first of all, let's understand what's a decision tree by its definition. As its definition, it is a non-parametric, non parametric as well as supervised supervised machine learning algorithm. Okay, so what do we mean by non-parametric and supervised machine learning algorithm? By saying non-parameters, we mean that we are not using any coefficient or parameters, unlike the linear regression or logistic regression. If you remember from linear regression, suppose we have an equation of ax plus by plus c. This a and b were coefficients, okay, coefficients or parameters, and in this problem we are not using any parameters, or in these algorithms we are not using any parameters. And what do we mean by supervised machine learning algorithms? By supervised, we means that if we are predicting something, or if you are classifying something based on the some outputs or some labels, then we are then that algorithm is as supervised machine learning algorithms. In this problem, if you see in the table, suppose we want to see if someone will go out for running or no, based on the three features of weather, temperature, or wind level. So we are predicting if someone will go out for running or no. So and we are using some features for predicting this, then it's called a supervised machine learning algorithm, like linear regression, like logistic regression. But unlike the clustering, that there is no label and there is no output, that's called an unsupervised machine learning algorithm. And the decision tree is a non-parametric and a supervised machine learning algorithm. Okay, after understanding this, let's see uh, the structure of the uh, decision tree. If you see, this is the a simple structure of a decision tree or classification tree. So today we specifically will talk about the classification tree. This is a node which sits on the top of the tree, which is called the root node. Root node, or we can short, in a short we can call it as root. We can call it as root. Then after the root node, there comes the some roots which lies in the middle, which is called the internal nodes. Internal nodes, and in the final we have the outputs, okay, which is called the leaf node. Leaf node or leaves, okay. And in decision tree algorithm, we can use this in two different ways. If we want to classify something, then it's called the classification tree. Not just we can classify things using the decision tree, but we can also predict something, or we can use it as regression tree, okay, for predicting some output or some level. So this is all about the definition and some background of the on decision tree. So now let's dive into the mathematics behind the decision tree. For that purpose, we are using a data set, a simple data set which is available here. We will predict if someone will go out for running, which is yes, and if someone will not go out for a running, which is no, based on the weather condition, the temperature, and the wind level. Okay, so let's select this table and paste it down. Okay, okay, so this is the table. Now, if you see the structure of the decision tree, we have the root node on the top, which is the most important node in a decision tree. For deciding like which feature should be on the top, we have something called impurity. We will calculate the impurity for each feature, and then we will decide based on the impurity that which feature should be on the top. For that purpose, we have to calculate the impurity for each feature or for each column. We will calculate for weather, we will calculate for temperature, and we will calculate for wind level. Whichever feature has the lowest impurity, then that feature would be on the top. Okay, so now let's start with the weather. Okay, we have now let's calculate the impurity for the weather. Weather, we have three different situation. All right, we have sunny, we have cloudy, and we have a rainy weather. Okay, so now let's see how many people will go out. If it is a sunny day, for people will go out, it is yes, and for people who won't go out, it's no. And for cloudy and for rainy. Okay, now let's count. Sunny, it is sunny day, one person will not go out, another person will go out, and the next person won't go out. So we have one person who will go out and two people who won't go out if it is a sunny weather. Now let's count this for cloudy. If it's cloudy, one, two, two person will go, two people will go out, and zero won't go out. Okay, so everyone will go out in a cloudy weather. For a rainy weather, if it is rainy, no one will go out. Okay, zero, and we have two people who won't go out. Now we have the count for sunny, for cloudy, and for the rainy. Now let's calculate the impurity. Okay, for calculating the impurity, we have a simple algorithm which is called Gini impurity. Okay, it is widely used for calculating impurities. Gini impurity. Okay, what is this Gini impurity? It will calculate how much impure is between the classes. So it basically calculates the impurity for a binary classification. The formula is 1 minus p1 probability of 1 to the power of 2 minus probability of class 2 to the power of 2. Now let's calculate that for sunny. G refers to the gene impurity of sunny is equals to 1 minus probability of yes is equals to 1 over 3 to the power 2, and minus probability of no, which is 2 over 3 to the power 2. So it will give us 1 minus 1 over 9 minus 4 over 9, which is basically 0.444. Okay, so now we have the gene impurity for the sunny. Now let's calculate the gene impurity for a cloudy day. Okay, for a cloudy day, if we calculate the g, okay, for cloudy, 1 minus, okay, for cloudy we have 2 for yes. Okay, 1 minus 2 over 2 to the power 2 minus for class no, we have 0 over 2 to the power of 2. Okay, this one will be 0 and this one will be 1. Okay, so 1 minus 1 is equals to 0. It means we don't have any impurity for the class of cloudy. It's obvious, right? We have two person who will go out if it's cloudy, no one will go out if it is uh, we don't have anyone who don't go out if it is cloudy. So basically it is very clear, if it is cloudy we will go out, if it is not cloudy we won't go out. Okay, so there is no impurity here, and similar to the cloudy, for the rainy also the impurity is 0. So we have the impurity only for the sunny. Okay, now we have the impurity for the sunny. Now we want to calculate the impurity, the total Gini impurity for the weather. For that purpose, we have uh, another term which is called the total. Okay, total Gini impurity. Okay, Gini impurity. For that purpose, we will calculate the weightage for each section times their Gini impurity. We have the sunny weather. For the sunny, like the weightage of the sunny, how many samples we have for the sunny? Three. Okay, the total sample is eight. So for the sunny weather, it is 3 over 7 times its impurity, which is 0.444, plus for cloudy we have two samples over 7 times 0, plus for the rainy we have 2 over 7 times 0. Okay, so these two terms will be 0. Okay, these two terms will be 0, and then we have the total Gini impurity, 3 times 0.444 over 7, which basically gives us the value of 0.188. Okay, so this is the Gini impurity, the total Gini impurity for the weather. Now we can we can note it down here, 0.188 for the, okay, for weather. Similar to this, we can calculate the Gini impurity for temperature and as well as for the wind level. We will follow the similar procedure. So for the temperature, uh, we can like divide this for the high, medium, and for low. We will see how many people will go out if it is high temperature, how many people want to go out if it is high temperature. Then for the low temperature and for the medium temperature, again we will calculate the Gini impurity for each of them. Then after that we will calculate the total Gini impurity for temperature and for the wind level. So for not taking much time of this tutorial, I have calculated them, and then I will paste it here so you can do by yourself and check with my answers. So for the temperature it is 0.214, 0.214, and for the wind level it is 0.331. So now we have the total Gini impurity for each feature. For the weather, it is 0.188. For the temperature, it is 0.214. And for the wind level, it is 0.331. So now we have the total Gini impurity. Now we will decide based on these values which one should go out. Should go on the top node or the root node. So as I said earlier, any feature which has the lowest impurity, that will be on the top. Now we can see that the temperature has lowest impurity. We will select this as the our root node. So let's do this, and let's select the whether as a root node, and let's make the tree. Now I will select this table and paste it down. Okay, let's put weather on the top. Now weather has three status or three different type of weather. We have sunny, then we have temperature, we have cloudy, and then we have rainy. Okay, for sunny, how many people will go out, how many people won't go out, and for cloudy, similar to that, same, and for rainy, same. Okay, now let's calculate, now let's count. For the sunny, one person will go out if it is raining, and two won't go out. For the cloudy, two will go out and zero who stays. And for the rainy, it is zero will go out and two people will stay inside. Okay, now you can see that this two has no impurity. Their totally mature. So this like this is totally clear. If it is cloudy, we will go outside. If it is not cloudy, we won't go outside. And for the rainy also. But for the sunny, it is not clear. So for this purpose, we need more to like to expand this tree and decide uh, based on which factor they will decide to go out or to not go out. Okay, because here we have some impurity. Now for this purpose, we will go to next feature. We will use another feature to decrease this impurity and to make this impurity as low as possible. Okay, for that purpose, we now have two other feature: temperature and wind level. For now, another question will come: which feature should we again select as the second top root node? Okay, so the topmost node, the second one. So for that purpose, again we can use temperature, and again we can use wind level, and then calculate the total gene impurity, which one has the lowest gene impurity, then we can go with that node. So now we can select the temperature. Now sunny, for the sunny weather, for three different temperature. Okay, if it is sunny and the temperature is high. Okay, high. If it is sunny and the temperature is medium, and if it is sunny and the temperature is low. Now let's see how many people will go out and how many people will stay in their houses. Okay, yes and no. If the temperature, if the weather is sunny, if the weather is sunny and the temperature is high, one person who won't go out, and then we don't have such a reading. So one no and zero yes. Okay, and for the medium temperature, if it is sunny and the temperature is medium, one person will go out and zero will stay inside. And then for the low temperature, if it is sunny and the temperature is low, one will okay, one will stay and zero will go out. So again, after this node, we can see that all the branches are like matured, and it's not like there is no impurity, and the impurity is zero. So now we can say that our decision tree is complete. So based on this decision tree, now we can we can predict if someone will go out or not go out based on the weather and the temperature situation. So this was about the decision tree, which is used for classification. I hope you have enjoyed this video. I will try to make another video on decision tree, which is used for the regression purposes. Thank you so much for watching the video, and please do not forget to like, comment if you have any questions, and if you have enjoyed the video, and subscribe to the channel. See you in our next video on decision tree for regression.